The sine rule. In this video, I'm going to cover the sine rule. Uh, the sine rule states that, for example, if we have got a triangle labeled as A, B, and C, we label the vertices with the capital English alphabets, and the side opposite to this angle A is labeled with small English alphabets small a. The side opposite to the angle B is labeled with small English alphabet B, and the angle C has got the side opposite to it labeled as small c. Okay, then the rule states that ratio of this sine of angle A to the side opposite to it, that is A, will be equal to ratio of sine of angle B by the side opposite to angle B, that is small b, and the same sine angle A divided by A is equal to sine of angle C divided by C, and we can equate this to this as well. So collectively we write sine of angle A divided by A equals to sine of angle B divided by B equals to sine of C divided by C, or we can write it down on the other way around as A divided by sine of angle A is equal to B by sine of B is equal to small c divided by sine of the angle C. Normally, I suggest my students that if you need to calculate any of the sides, either A, B, or C, so use this format, keeping the side in the numerator. And if you need to find out an angle like either A or B or C, so use this format in which the angle is there in the numerator. Okay, now this format can also be used in this format: sine of angle A divided by A is equal to sine of B divided by B. Now let's see and let's analyze what is it telling us. It tells us that given this angle A and the side opposite to it, and this angle B and the side opposite to this angle. Now we have got four quantities, two angles and the two opposite sides. Out of these four sides, given any three, we can find the fourth one. So this is what we need to keep in mind. Similarly, if we equate this to sine of C divided by C, even if I equate this to this, or even if I equate this to this, that means the same thing. So to apply this sine rule, what we require, we would be having any two angles of a triangle and the sides opposite to those two angles. S- Altogether, we would be having four quantities involved in a particular question, and we would be given with any three quantities, and we would be required to find out the fourth one. So this is the uh, whole essence of this sine rule, and now I proceed to solving some questions using this sine rule. This is exercise 15.11. Find the value of x in each of the following equations. In part A, x will be equal to 9 divided by sine of 98, and I'm going to shift this sine 50 to the other side, and it will get multiplied by this fraction. There is a bit of clarity that I need to uh, make here. Normally students do it that sine 50 times 9 divided by sine 98. There might be a chance that if the calculator is not using bracket here and you are not using bracket here or actually here, so the answer might be wrong considering the bracket like this. So the calculator might be multiplying 50 by 9 first and then calculating its sine. So that should not be the case. Rather, we have got an angle 50 whose sine is there to be multiplied by the number 9 only. So this is what we need to take care of. Okay, now if I use calculator for this, so this will be, it's better to use this fraction key, 9 times sine 50, and then in the denominator this is sine 98. So this can give us the answer to be 6.96. That is the value of the variable x for part A. In the same way, we can do its part B, that x is 20 divided by sine 100 times sine 25. So we can do it like this using this fraction key, 20 times sine 25 whole divided by sine of 100. So the answer is 8.58. Same goes for part C, that we just need to multiply sine 70 here. So it is going to be 20.6 times sine 70 divided by sine 50. And the answer is 25.269 for part C. The answer is 25.27. That is the value of x. Okay. Now there is something special about part D, because in part D we need to find out the angle x whose sine is what is we are given with. So in part D, I'm going to do it first of all. Sine of x is equal to sine of 63 divided by 16.2, and then this is 11.4, which is being multiplied with this fraction, and then finally the value of x is going to be sine inverse of this whole thing, as I told you earlier. So I'm going to write down, it's better to write down 11.4 first and then write sine of 63 whole divided by 16.2. So shift sign, then this is the fraction, 11.4 times sine 63 divided by 16.2, and then I need to use this bracket because this is what is required to calculate the sine inverse of the whole thing. So the value of x, it is going to be 38.829, and writing it down to two decimal places, since this is the angle. So angle is written to one decimal place only. So 38.8 degrees. That is the value of x. So this is how we do these questions. Okay, then it is question number 2 now. Find the length of the side marked x in each of the following triangles. Now the side is x, opposite to that side is the angle 65, and then 9 and 50 are opposite to one another. So I'm going to use the second form of the sine rule, that means the side is there in the numerator divided by sine of the angle opposite to that side is equal to then the side given in the other case divided by sine of the opposite angle, that is sine 50. So now in this case I'm going to have 9 times sine 65 divided by sine 50. This is going to give me the answer. So 9 times sine 65 whole divided by sine 50. Answer is 10.6479. I use the unit centimeter because the other side is already given in the same unit centimeter. So that's why the value of x is given in centimeters, 10.65 centimeters. Okay. Now for part B, x is opposite to the angle 33 and angle 72 is opposite to the side 10 centimeters. So x divided by sine of the angle 33 degrees equals to 10 divided by sine of 72 degrees. So that gives us 10 times sine 33 whole divided by sine 72 degrees. In this question, you need to observe that we haven't used this angle 75 because it is not uh, involved in the given scenario. We are given with the side and we need to use the angle opposite to that side, and then same goes for this pair. Okay, now calculating the values. This is 10 times sine 33 divided by sine 72. So the answer is 5.726. And in the same way, we can calculate this part C and the value of x by writing x divided by sine 25 degrees is equal to 6 divided by sine of 35 degrees. And then we can make x the subject, and the answer is going to be actually calculated by shifting this sine 25 on the other side, and this will give us the required answer. 6 times sine 25 degrees divided by sine 35 degrees. Make it sure that when you are using your calculator, the calculator is given in the degree mode. So this is the answer to part C. In the same way, the remaining parts are to be done. So I'm just proceeding to the next question, question number 3. Find the size of the angle marked theta in the following triangles. Now we need to find out the angle. So angle that is equal opposite to 9 centimeters and 65 degrees angle is equal to is opposite to the side 10 centimeters. So I'm going to use the first form of the sine rule, that is angle that is to be found out, that is to be kept in the numerator and then divided by the side opposite to that, that is 9, and then sine of 65 degrees divided by 10. So now first of all I need to shift this 9 to the other side. So this is going to be sine of theta is equal to and with this I need to multiply 9, and then to calculate the angle theta I need to shift this sine to the other side and it is going to be evaluated as sine inverse of this expression. So now using our calculator, this is shift sign that gives us sine inverse actually. So shift sign of this fraction 9 times sine 65 degrees whole divided by 10. So the answer is 54.65. And since this is the angle, and angles are given to one decimal place, so I should be writing 54.7 degrees. So that's how we calculate angle using the sine rule. Okay, then again we need to calculate this angle theta here in all these parts. So let me solve part C first. So theta will be equal to sine inverse of what was the angle, that is 60, and the side opposite to that was 6. So sine of 60 degrees divided by 6 centimeters. Let me not write down the centimeters, and then I need to multiply it with 6.5, this one, as we did in part A. So I can calculate it directly. Actually, okay, let me do it. Let me do the first step first actually. How I calculated this thing. Sine of theta divided by the side opposite to that, that was 6.5, is equal to sine of 60 degrees divided by 6. Now, first of all, I shifted this 6.5 to the other side. It got multiplied with this fraction. And then I shifted this sign to the other side to have written as shift sign or sine inverse. Now I just need to calculate the values. So shift sign, then 6.5 within this fraction times sine 60 divided by 6, and the answer is 69.75. So that is going to be written as 69.8 degrees, since we write angles up to one decimal place. Okay. Then the remaining parts are to be done exactly in the same pattern. If I do, for example, part F, this can be written as sine of theta divided by the opposite side, that is 11.8, equals to sine of this angle divided by this. And then now I need to have written as sine theta is equal to 11.8 to be multiplied with, and then I need to shift this sine to the other side, so the value of theta is going to be sine inverse of 11.8 times sine 37 degrees whole divided by 9.2. So it's better to use the calculator now. Shift sine, then the use of this fraction, 11.8 times sine 37, then whole divided by 9.2. So the answer is 50.524. 50.52. So this is going to be written as 50.5. Okay, with all this concepts clarity and questions practice, now I proceed to question number 4. In triangle ABC, angle A is 72 degrees, B is 45 degrees, and side AB is 20 centimeters. Calculate the size of angle C and the lengths of the sides AC and BC. Okay, since I'm given with this side, so I need to have the angle opposite to this side. And since we know that the angle sum of the triangle angles is 180 degrees, so I should write angle A plus angle B plus angle C, that is equal to 180 degrees. Angle A is 72, B is 45 degrees, so 117 plus angle C is equal to 180. So angle C is 63 degrees. Now once I've calculated this angle C to be 63 degrees, now I can use the sine rule. Since I need to calculate side AC, so I am using this as x. So x divided by the sine of the angle opposite to this. So this is sine 45 is equal to, now I need to use this pair. The pair that was given in the form of 20 and then angle C, that is what we have found out now. So 20 divided by sine of 63 degrees. So the value of x is 20 times sine 45 degrees divided by sine of 63 degrees. So now since we need to calculate the side, so to calculate the side x, I haven't used the sine inverse format, because that sine inverse is to calculate the angle, not the side. And then sine 45 divided by sine of 63 degrees. So the answer is going to be 15.87. That is equal to the side AC, and then to calculate the side BC, let me call it as Y. So Y will be equal to, using the same thing, 20 divided by sine 63 times sine of 72. Now I use this one. So that will give me the required answer. 20 times sine 72 degrees divided by sine 63.